Good afternoon. Good afternoon. Much better. So welcome to September's Datagiri event in association with Barclays. A picture of hands from the members of the audience who all are first-time attendees. And they're all in the back rows. Interesting. But that's a cool thing. So I want to quickly touch on what Datagiri is and what we do. So this is a data science community that extends across the globe now. We started in 2016, and all we started as an experiment to see what kind of data science, what kind of community, what kind of professionals exist in this country. So it was a very small experiment that took off really well. And what started as a very small community in 2016 has now snowballed into this. So we are about 100,000 people strong today. We have 13 chapters across India and also in the UK. And just this last month, we did our first event in the UK, received a great response. We got a lot of professionals, and it was a very big event.
Hi guys, my name is Mayuresh. I am sure you must have received some emails from me. Fantastic. So we have Ranga over here, Ranga Rajan Vasudevan. Can you just raise your hands? Thank you so much. So will be the speaker number 2 over here, speaker number 3 over here. And we also have Abhishek. Abhishek, can you just raise your hand? Fantastic, thank you so much. We also have with us Dr. Isaac Ben Akiva. If you can just raise your hand. Fantastic. We'll be starting off the session with very first address over here. Thank you so much. So guys, I think I saw a lot of people over here who are coming to Datagiri for the first time. Perfect. How many of you are like practicing data science in some capacity? Okay, fantastic. And how many of you are kind of aspirants wanting to get into it? What's the nice? How many of you are working in some sort of a fintech or bank or insurance from the BFSI sector? Okay, very interesting. Great, thank you so much.
So I'm going to start with speaker introductions first. Our first speaker is Dr. Isaac Ben Akiva. He's the head of machine learning at Barclays. He has over 20 years of experience in intelligent systems, software development, architecture and management. He has a PhD in machine learning from the University of Toronto and has several other specializations in machine learning and deep learning. He has applied machine learning in the past to solve challenges in HR and hiring, fraud detection in the financial sector, in military defense applications like unmanned aerial vehicles, sentiment analysis and pattern recognition in the field of marketing, speech recognition and text analysis, and robotics. Our second speaker is Mr. Abhishek Kothari, who is the co-founder at Flexi Loans. He's a graduate of IIT Bombay, and he holds an MBA from ISB Hyderabad. He's an analytics and consulting professional with a rich understanding of data to insight landscape. He has previously worked with over 20 clients across the UK and the US, and he has provided solutions in digital analytics, marketing analytics, risk analytics, web analytics, operations optimization, and business intelligence setup. He has also managed CXO mandated programs and has provided significant financial upside to organizations across the globe. His areas of interest are essentially anything that has data in it. He's specifically also interested in data monetization and data innovation center setup. Our final and third speaker for the day is Mr. Rangarajan Vasudevan. He's the CEO at the Data team. Mr. Vasudevan is extremely passionate about helping companies grow through the power of data and data science. He has experience in solution selling, business development, partner engagement, training and mentoring. He has a strong academic background in core computer science topics like databases, distributed systems, networking, software development, data mining, and algorithms. So, without any further ado, let's welcome on stage our very first speaker, Dr. Isaac Ben Akiva.
Thank you for having me here, first of all. It's really a pleasure to be talking to this great audience in here. We're going to be talking about the future of an AI, machine learning, so to speak, because that's what an AI is today, right? Machine learning. We're going to go through the steps that machine learning took to get to here. We're going to be very briefly talking about the history of the AI or machine learning itself, and what can we expect in the future, specifically within the financial services area. So to start with, let's have a brief history of an AI. Just to think that an AI is a little bit over 60 years old. It's not a new field. It is new the way that we're applying it today, the adoption that it's having the market today. However, the academic field of artificial intelligence was set up back in 1956. And since then, AI has ups and lows, both lows than ups. But we got to the point today where we have the setting of technology that's enabled the practice of machine learning to a high level. Specifically, if we say we have a very strong computer processing nowadays, we have available data with an expanding capacity, and this kind of background, this kind of infrastructure, enable us to apply machine learning to the level that we have it currently. It enables us, to get to the point where we can develop a new algorithm and have these algorithms solving real-world problems, real-world business problems as well. Okay, and another thing that sped up the development of machine learning in the latest, frankly speaking, 10 years, it's where we have really a boost in machine learning. It was the talent, it was the people, not only academic, not only pursuing academic interest, but engineers trying to solve problems. And that's how we got the machine learning to the step that we are today, or the spring that it is today, because when you apply, when you try to solve a real world problem, real business problem, then you have the funding to do more research and develop new algorithms, new ways to solve another problem. So these recipe of things, the computational power, the available data, the necessary funding because you are developing a new technology to solve in a real world problem, a specifically business problem, then you have all the necessary ingredients to flourish, to go forward. And we got in here, we got to the steps where the status where we are with the current practice of AI and machine learning. However, there is still a long way to go. There is still many problems that we can't solve at the moment. We can't solve at the moment that maybe with a different approach. For example, structured learning. Having a huge amount of data that we still needed to normalize it, to process it in some way, to bring it in a way that where we can apply current algorithm. However, in the future, maybe we can do it straight, without this normalization process. So, this is just this this brief in history is just really to set a pace and for what can we expect, in the future. Just to analyze a little bit that, from 1956, where we get to today, specifically if you think 1956 to beginning of 1990s, the practice of AI, machine learning, it was nothing. It was only an academic pursuit. When I started my PhD in the 90s, interestingly, my supervisor, and I studied under Geoffrey Hinton, he told me, do you intend to work in academia? Because if not, you're going to be jobless. There is nowhere we're going to apply this. And would I take his advice, not in studying it, I wouldn't be here today. So, from 1956 to the beginning of 1990s, we had a very little development in the field. But from 1990, specifically beginning of the 2000, to today, we had a huge boost in the development, and not only the application of machine learning, but the development of new algorithm, convolutional neural network happening there, recurrent neural network, and even really deep learning with the back propagation, and Geoffrey Hinton, start that in what, if I'm not wrong, 1992 or even later than that. So really in the last, we could say, the last 18 years that AI has had a huge advancement. So if in 18 years we could get where we are, with that level of technology that we had in the beginning of the 90s, what can we achieve in the next 10 years? I think it would be exponential, the advancement that we will have. So, however, any advancement comes, any new technology comes with opportunities, big opportunities, its challenges, and the impact that it can have in society. And machine learning, or AI, so to speak, is not different of any other disruptive technology that came. And the people are right, to fear AI. Personally, I don't believe that we're going to have, robots rebelling against us and trying to kill us. However, there will be some disruption in society, how things are done. Okay. We're going to analyze in these slides that we have here some of the opportunities that exist in application AI within businesses, specifically within the financial services, how we at Barclays are currently tapping into those technologies to improve our business operation, to have a better engagement with our customers. Ultimately, that's what we want to achieve, to offer better products, more customizable to the needs of our customers. However, these new technologies bring some challenges to us. Challenge the way that we deal with data, how we collect the data and store data. We have a huge amount of data. Are those data there in the right format? So that's a huge work that we need to do as well to prepare the data. As we know, I think everyone must have heard it, they're saying that the life in the day working of a data scientist, in 60 to 80% of it is into data preparation, data cleaning, normalization, and that is a fact. We have that amount of data there that needs to be worked with, the prepared, restore, and so on. However, in the financial service, you have another challenge that is the privacy. We have regulators, heavily regulating how we deal with data, how you are, applying algorithms on top of the data, and if you are sharing that data or not, how you acquire the data, and so on and so forth. And the changes that it is going to bring, into society, for individuals itself, for our customer itself, but then also to our employees, to our colleagues. Currently, at Barclays, we are very much focused and improving our customer relationship, our customer engagement. We are not developing machine learning models that will impact our colleagues. In other words, that will cause colleagues to lose their job. That is now, but what is going to be in 2-3 years time? I do believe automation will take place, and that will impact people will lose jobs. People will need to be retrained and acquire new skills to be able to continue working. So those are not details that needed to be tackled as well. So let's talk a little bit about the opportunities. That's in fact why we are here, right? What can we do with machine learning, and what are we doing with machine learning and AI? In fact, I'm going to stop using the term AI and use specifically machine learning because, within the subfield of artificial intelligence, machine learning is the most prominent one. It's how we can achieve currently machine intelligence. This is to teach them to learn from data, so they recognize and depart from data. So let's concentrate only on machine learning. So within these opportunities, I think we could divide it in 5 categories. Things that we are doing currently and things that we can do radically different. I think, do radically different because we needed to start from one point, right? We are not jumping to the end of the track, but we're starting really from the beginning on. So when people are talking about machine learning or talking about, and again, AI, in fact, we are talking about some things that is very practical. We are talking about identifying pattern. You are talking about making predictions or forecasting, right? And you're talking about segmenting your customer base as well. Again, is identifying a pattern in there, and decision making. Those are the areas that is being tackled today with machine learning. And from those categories here, the five categories that we have lean operations that is trying to make it faster and better your current task network. The second one is tailoring, that is basically trying to create products and service very much customized to your customer, to client base, or in other words, identifying grouping of customers that a given product within your line of products is more suitable to. Like thinking about the recommendation engine in here. Then we have the ubiquitous, machine learning, that your product is everywhere. The customers is engaged with you seamlessly, throughout the different channels. And more importantly, the channel that is more suitable to every given customers. So that's an important aspect to do, is to understand how your customer prefer to relate with you. Then we have the decision making, we have the pattern recognition or the segmentation that I mentioned before. The other two is smart decision making. So algorithms, the machine learning is there exactly to help us in that. So that one of the biggest strength is exactly the predictions. And the next step is really bringing a strong value proposition. That, I would say, is thinking radically different and creating products that will change your business, that will change the financial service. We are still not there yet, but definitely that are things that will happen in a few years and ahead. Banking will change. New players will come within the finance areas with a completely revolutionized product based on artificial intelligence that will engage deeply within the customer. So within the area of that we saw here, let's analyze what exists currently in the market and for every one of these categories here. So in the lean and the faster, we have in the products nowadays that deals with automation, automated personnel and business loans, products that help identify specifically the needs that every customer has in terms of loan, and automatically can, and if it qualifies, obviously, if it qualifies to the loan to be received. So those payments and as well intelligent data cataloging and compliance and how the banks are doing the service in finances and dealing with the customers finance and so on. And another example I could give is ID verification. That is automatic onboarding that uses computer vision to identify the documentation that the customers present. So nowadays, instead of going to pop into a branch and to present your passport or your national ID cards and open an account, you could do that over your mobile phone. Okay, using the banking application, apply for a new account and do the entire authentication or verification of your ID, over the mobile phone, using image recognition and so on. Another area that we have is tailored products. Tailored products, we can think in a lot of recommendation engines, as in Amazon and Google, use a recommendation to identify what kind of products or service you are most interested, or the search that you read. We have the same thing also in banking. And at Barclays, we are using this powerful technique as well. And this is an example of this is recommend the best rewards to the customers. Instead of showing all the rewards that is available in there, what is the one that the customer would be more engaged, much more interested and solve it. So that this is an example of tailoring the services or setting of products to the customers. Another case is in terms of offering the right loan for the customer, the right product to a customer as well. It's tailoring your service to what is really want. And machine learning is very strong in this area. What we have as well is ubiquitous presence. The ubiquitous presence is different channels. We can think how you can communicate with each and every customers. And that is not only you offering the given service, offering maybe a mobile application, offering your web presence, but I think as well the content that they're offering. If you have a real-time decisioning environment that you can identify, it was a customer X that is logging in here. This customer, he likes to spend money in clothing, in high fashion. He likes traveling a lot, and he travels. His preference travel is Western Europe. So you can tailor the content that you're showing to the customers to what he likes. Or if he's someone that very much into finance and his personal finance, he wants to increase his wealth. So you would be offering content that is very much towards savings, towards investment account or funds and so on and so forth. And so this is a seamless to the customer and is applied to different channels as well. It's applied to communication, how also you want to communicate to the customers. Are you communicating through email, so the SMS, the mobile app notification, so different ways that you can identify and be present in the customer's life, without the customers really being aware of that. And then we go to prediction, that is smart, the decision. That is one of the areas that machine learning has been used throughout financial service. You have these investment in the banking and so on. So it's I think it is the most mature case of an application of machine learning in decision making process. And some examples that we have in here that things can be the next generation of an application within financial service. Specifically, we want these in high investment assets management and so on. Maybe an example that we couldn't have here is a deep customer representation where you is able to understand your customer from different perspectives, from behavioral, from the psychological, from the financial, and so on. And that way you can tailor very much your products and services to that customer base. And so this is just some examples of what exists nowadays and the possibilities ahead for machine learning. Now, how are we using it within Barclays? That will be the next one. So stepping a little bit back, we started this section talking about 3 points: the opportunities, the challenges, and the societal challenges, the societal impacts. In fact, so when the challenge that we have, and as I mentioned briefly before, we have in the data. how that data, the quality of the data, how we store that data, and the access of data. Access a data, it looks simple, maybe for different sector of the industry, it's simpler than it is within the financial service. Not in everyone, not in every single data scientist can have access to all data within the bank. You have an access to specific data which in your business area within the bank is working on. Anything else is depending on a series of approval. So if you wanted to become a data-driven organization that makes use of the machine learning, you needed to have a seamless and quick access to the data. Okay, that is a big challenge that we have within the financial sector. Another challenge is the regulations that apply to that data. Especially if you think nowadays that in Europe and you have the GDPR, regulation that requires that customer data is anonymized, and even to run models on top of that data, you needed to pre-process that. You needed to take into consideration those details. Is there here any piece of any features that can identify given customers, and am I being, you need to thinking about, am I being biased somehow? Bias within the data is another very interesting, and recently IBM published a piece of work and specifically looking at that. Are we creating biases that will in certain aspect impact the society? The poor will become even poorer, or the richer, we're going to be benefited. And so those are the things that you needed to look at. And the last point in here is about the societal implications. As I mentioned before, jobs are going to be impacted. The way that financial services is going to operate and as well going to impact, and may impact the society in general. Maybe if you don't really prepare for that, it may be the case that machine learning models will benefit much more people with wealth than people without wealth. So we're going to need smart investments, Robin advisors, models that identify the best type of investment for you. Certainly that's going to benefit who has money to invest, but who doesn't have, you're going to continue in that situation. But the point is that it will be automated, completely automated. So those are some of the impacts that you're going to have. And that mass of people that are going to be dislodged, of their jobs, needed to be retrained. The big job loss always impacted the society. That cause an economic distress, and ultimately may cause a huge economic depression within the country or in the region because many people are out of employment. So, what areas of machine learning or what areas within the financial service are making a stronger use of machine learning? We've seen, and we're going to see a little bit later on how we are doing this at Barclays, but we could say that most of the financial institutions are going in the same direction, using machine learning for customer engagement, for customer facing, and most of these is in the area of chatbots. You guys must be using chatbots within your banking application. Another area is in the fraud detection itself, that being different in cases of fraud, being it from ATM cash withdrawal fraud to more the crime cases like money laundering or what we call the mule account. So trying to legalize unlegitimate money or money that was gained through crime, like drugs and so on. into legit money. So those are the areas that we are applying as well. And in general, it's being applied in the financial sector, obviously in the area of credit and risk, in the area of recommendation engines. So this is, we could say that the market in the sector is quite mature in the application of machine learning within these areas. Obviously, within Barclays, we are very much aligned with this, but we are trying not to follow only what is being done in the market. We try to innovate and prepare for the future. So in terms of machine learning application specific cases, we have, things in image recognition. So we are developing, in fact, a model to be able to identify handwritten recognition from different type of forms and extract that text. So think there the use of deep learning for that, CNN, LSTM as well. Then we have the case of contextual search, of search engine, again using deep learning as well, thinking about that in word and embedding. So some of the technologies that you guys certainly recognize, and some of you must use in your day-to-day, that must be learning. Besides that, we have the usual case of predictions. For example, loan prediction or prediction. Another example prediction we try to is tackle very specific kind of problems that the bank can face. Okay, you are calling into our call center. What is the probability that we're gonna complain? Are you calling to solve a normal transaction, or are you calling to complain about a failure from our side, or a misunderstanding that you have? So we always, we have to pay fees for a service that you acquire. So sometimes that fees wasn't understood by you, or it was higher than you expected for any reason. So there are cases that customers, this is normal in any business, are not happy with a given transactions and wants to complain. In the financial sector, a complaint is something that's taken very seriously, something that needs to be reported to the regulators itself. So it's very important that we deal with that we be proactive in dealing with complaints. So yes, we then have models that try to identify if a customer, try to predict that thing, if a customer going to complain or not. So we have, I would say, things in those projects that I'm showing that we currently are deploying. We have things more, let's say, traditional machine learning models. We're working with some random foresting, XGBoost, and some of the models, to more advanced deep learning models and that. And deep learning models applied also to natural language processing. And another thing that I forgot to mention, some of the projects that we're doing here also applied NLP, both from the standpoint of sentiment analysis, understanding how the customers are relating to the bank, and understanding also the level of engagement in the customers in the bank, how they are mentioning the bank in social media. Also to try to understand the main reason why the customers are complaining as well. Okay, so NLP and deep learning is another piece of machine learning techniques that we're using. As I mentioned before, we use NLP for image recognition problems, and we are applying also in the different projects that we're running. So, but how can you be successful in implementing machine learning in a big organization? There are a few steps that is necessary. One is establishing the right process. I know that is much more interesting to be there doing the coding, to be developing the model itself, dealing with data and predicting. But if you think from the perspective, managers and the organization itself, that's why this talk is very much focused in that area. How can you get it right and what is the future to it, how we are making use of it in the future. So it's very important that you develop something in a methodological way and a reproducible way. For that, it's very important to have in place a strong data science process where you have milestones and you have the deliverables in each milestone, and you can measure the progress of your project. The data science per se is an exploratory activity. And exploratory activity, may be something almost endless. You are never happy. You are always looking for the best in accuracy. Oh, I'm 72%. I can get to 75. Now I can get to 80, and so on and so forth. And that's it goes forever. However, we needed to get in a project now to there. We need to get enough products, deployed and with the benefits. And maybe 75% is enough to solve the business problem. Okay, or it's not enough. Where you need to say, now is the time to finish. We can't go anymore. We waste already a lot of time in this. So it's very important to have a solid, data science process. And another thing is, the second step is to have a very clear objective. What you wanted to achieve? What is the business problem? The business statement that you want to solve with your model, and what are the success criteria or the KPIs? It's very important to have those steps as well. Those very well set. And the next step is a robust, architecture. And that's not only for really the infrastructure that you have there. What am I using? Is it a Hadoop infrastructure within the Spark? And so, or is it a more local solution running on Python? Or you're going to deploy these on a server, a web server, or whatever way. And not only the model, okay? You have the model, fantastic, develop it on Spark, it's running on Hadoop, but how will ultimately, your, let's say, end customer use it within, the bank that, and how you're going to integrate these with the remainder of the solution, the remainder softwares that you have within the bank. You're going to develop a UI, a web UI where the user, your internal user I'm talking about, is going to use that application or the insights that were generated by the model, or does the model need to be directly integrated with an already existing application within the bank? Is that to be something that's going to be customer facing, for example, a chatbot? How do you going to integrate that? So that is really part of a very robust architecture that needs to be thought, from the beginning. And then the other thing is applying the right algorithm. Okay, you don't need to choose the most modern or the most recent algorithm to try to solve a given problem. Sometimes you go for the first the most used algorithm. Okay, let's have a random forest here. You're gonna solve my prediction problem. Oh no, let's use a deep neural network. That is the solution. Have you tried a simple linear regression first? Have you established a baseline? Okay, that yes, within a very simple model, I can achieve X% in accuracy or whatever metric is I use in that. If you do that within a simple model, then from now, okay, I have a baseline. Now, what can I do with a more advanced model? which fine tuning do I need to do. Then you go for a random forest, then you go to SVG boost, or you go to an ensemble model, stacking different models, and then even the deep learning. So, but first, always try, simple model, establish your baseline, and then grow from there. And the last point to mention is a very clear, more lucid, visualization of the insights. That's where it's very important to have, especially if it's for business intelligence, to have a clear view of the insights, to make it clear for the consumer of your model to understand what they're saying. How does that impact? So having a very appealing, a very strong UI, graph based with some charts, comparisons, and so on. This is very strong, as a final solution. Okay. And how can you achieve this? I think, you can't achieve none of those without having a champion team. And within data science and machine learning in general, I would say a strong team is a multidisciplinary team. To bring it to develop a model is one thing. We are talking about developing an application where that model is a part of it. So that model is going to bring an insight to it. So to develop an application that ultimately going to solve a business problem, you need a multidisciplinary team. You need a software architect to see how the application going to scale. How should this be integrated within the remainder of the system? The data, how is it going to be prepared and ultimately used within your model? So you need those players there. You need the big data engineers. You need big data architect and software architect. And UI front end. If you are working, on the web, you intend to deploy your model as a REST and full API, or if you intend to deploy your model as really a web application, you need to have, front end, UI developers there. You need to have a software developer there that you'll be able to put up in your, web service solution, and so on. So. And not only that, I would say for per project, you needed to have also people that is the data specialist. You need to have people that is a subject matter experts that will help you validate, what you are doing, validating if the insights that you are getting is the right ones or not. So it's very important to have a mix, of the people for any given machine learning project. And I think this is, I was talking a few months ago with our peer speaker, Rangan, about the importance, of applications to have out there and the feedback that you receive. And in fact, it's very important to get, and I do compare machine learning development a little bit with the mobile application development. Some do not intended to create a very robust application when it is really, achieving 99% of accuracy that you're going to deploy. No, deploy quick and update quick. Okay, because once you deploy, your application, the user started refining that application, started giving you feedback, and started using your application, which is going to generate more data that you're going to use it to retrain your model, to revalidate your model, and then you deploy the next version, and that will continue. So you enter really in the virtuous cycle of data. The better application you give it to the user, the more they're going to use, the more data you're going to generate, the better then you can make your application, so you continue that in the process. And this is one of the steps that we see currently in the machine learning world, and the big corporations are using that, and we are following those steps as well in this aspect. We are almost there. The point is, in terms of the Barclays, what we intended to do machine learning in the future, and how we intend to use it. We intended to use machine learning in a more different, a more, let's say, engaging way with the customer. Our objective is to be able to understand our customers deeply, so we can create a product that is very customized to each one of those marketing segments and meet their needs in that. And for this, we can imagine, some use of machine learning in a more detailed recommendation engine, in creating, specific segments. But besides that, we needed to we have also some operational functions that we needed to make. Some of that is the regulation, so we have regulatory technology, which we can apply, for example, natural language processing to summarize the documentation and analyze the impact that new regulation has within the bank, and if we are applying all the regulations that are already there. Credit risk forecasts that we are still not using machine learning specifically. If you're thinking about a loan for big or for small businesses. And another thing that is very important that we are also not using is in cybercrime. Besides fraud detection, we can think they use and also in different cases, like hacker threats and so on, 0-day kind of threats. Machine learning, certainly you're going to be using in these areas as well. Okay. So I think I mentioned about that as well, so I'm not going deep in here, but the point is challenges and implications are there in machine learning. We need to think about the ethical dilemma that we have in it. We're going to develop the more applications that we automate the entire process in a bank, and how this is going to impact the customer, society, the way that we are competing with other banks, the regulations, and so on. So those are very important considerations that we need to have. And balancing the change that we, I think we're talking about that briefly before I mentioned it. But yes, it's a word that currently we are making use of our own data. However, in the future, we're gonna be, having to collaborate more and more with the other banks, collaborating more and more with our own customers as well. Again, if you're thinking in Europe, in GDPR, now if you want to use the customer data, you needed to get their consent to use the data to make predictions, even to work in more recommendation. So it will be an exchange. You're going to need to be more transparent with the customers, how we are using the data to get more data from them. And in the future, we're going to have this collaboration with the institution as well. This is a exchanging of the data. An example, again, in the UK, you have the open banking, that banks in certain aspects exchange current data, so we can do payments or transfer or even checking for loan application and so on. The future is very difficult to predict. I'm not trying to I will not even get there to try to predict the future. How many predictions in this area, specifically of machine learning, has gone wrong? Some talking about robots that we could solve on a project. According to some of the earliest academics within machine learning, by now wouldn't have robots controlling our life and doing all of the work, and we are not there. So I'm not going to that in this step, but what I could say, we're going to see massively in the next probably 5 years it's a huge adoption within the sector. You're going to scale what we have today. So chatbots, for example, you're going to be much more engaging with you. Most of the transactions that you're going to be doing in a bank, you're going to be through chatbots. You're going to be seamless. Payments, you're going to be seamless. I do expect that in the future, we're going to enter into a shop, we're going to enter into a bank, and you don't need it to go and take your credit card or your debit card. You're going to end up pay. As you see some Amazon shops, that you go in, get out, you see the products, identify what you're doing, identify you, correlate that to match that with your account, and see the products that you took and so on. We're gonna see really massive in the next 5 years automation of the financial process. And the adoption of new applications of machine learning, in areas as forecasting, as investment, and as risk analysis, operational risk analysis, like for example liquidity. So the asset, the money that the bank needs to have, to cover for a given period. So those are basically the points that I would like to talk to you. What we are doing at Barclays currently in terms of machine learning. We are very much interested in acquiring talent. Talent is one of the biggest challenges within this area today. We saw that machine learning had a huge low period, or the winter as it's known. So to find the currently talented experts in the area with experience, it's very difficult. So we are looking for new talents, and you encouraging you to apply for a position. We have our colleagues in here, Abi, Kapil, Himanshu, Parimal, and others that you can refer after the event at the end. So I extend first to them a big thank you for organizing this event and to being here today. And feel free, if you're interested, to apply in a position in this area within Barclays. We have a huge future ahead. Currently, we are working in over 20, in just 1 year, working over 20 projects in this area of machine learning. We see in the next few months we're going to start a few other projects, and in the years to come we're going to see a huge increase in projects in machine learning to automate in our process, to optimize what we are doing currently, make it better, and to really find, as we saw before, a radical application of machine learning, things that can radically reinvent the way that you're doing banking. So thank you very much, and contacting us then. And thank you, the team, for getting to this level.
Thanks, Doc. So we're going to bring a small exception here and take 3 short questions from the members of the audience for Dr. Ben Akiva.
How do you see the way ahead for cryptocurrency in the banking sector, and way it will get matured in the due course?
Cryptocurrency. That is, I would say, a little bit out of my area of expertise. I could give maybe my personal opinion, not my professional opinion, because it's a very completely out of it. I don't think, personally, I don't think that you're gonna be, the big way ahead. Definitely, I may be wrong, but I don't think it's gonna be a strong boost. We've been seeing blockchains and the technology like that in the market, but having a very small growth. I would see, for example, blockchain used in different applications as let's say legitimatizing or tracking purchase. Thinking about, for example, a piece of artwork. Okay, there is Mona Lisa. Suppose someone's back Mona Lisa, you needed to have a lineage track to make sure that that is really the original piece of work. So I do think that kind of technology, will really survive and it can be used in different applications. Now, in the space of cryptocurrency, personally, again, as I said, I'm not a specialist and I don't touch in that area. I don't think that will, last in the market for that long. Just my personal view.
I heard you talking about creating a baseline model, for example, linear or logistic in this case, and then going forward with random and XGBoost. So, for example, if you are solving a churn problem, propensity model, and if you want to identify the people who are churning out, and we want to identify the reasons also why they churn out. For example, XGBoost or random forest is more of a black box model. We really don't identify what is the reason that we are giving that particular person of that particular entity a high probability of churn. So, is there any defined way which we can make these black box models like XGBoost more interpretable?
I would say XGBoost or random forest, that's in fact what some people used to do. Sometimes apply random forest to give you a better view of a feature's importance. And then you go and develop it in a different model. That could be a way that you could try to, identify how the same set of features that you selected, are performing a different model like an XGBoost. So that could be a way. Another way is already to do your, statistical analysis on top of the features that you set. How are they correlating and so on. That's why it's very important. Before really choosing a model, go to the steps of an exploratory data analysis. And understanding more detail your data set, which will help you, choose the right set of features or create new features that would give, your model a good, prediction factor.
I have a question about the financial situation by using AI, because most of the banks and institutions I speak with, they are very wary of justifying the cost of investment in AI.
Mm-hmm.
Does Barclays, are you able to do it in Barclays, where you are able to say whatever investment you have done in AI, there's the return which you are getting in terms of monitoring?
Mm-hmm. Yeah, that's a very interesting question. I think in every financial institution, every in fact, big corporation applying machine learning or applying AI, so to speak, is facing the same situation. First, it is a very new, in terms of adoption, technology. Okay, now that companies are starting seriously looking at it, especially bigger corporations, seriously looking at it and bringing it in. Having, doing the mathematics of a returning investment, we still haven't done that yet. We have in our, let's say, baby steps, so in terms of application of machine learning within the bank today. This is the first year that we start massively applying it. We are looking into, I think looking for success story. Okay, so we are developing solutions for problems that is what we call the low-hanging fruits. Problems, simple problems that's not there, and let's evaluate in how this is gonna play, how our infrastructure, needed to be changed to support it. And so we have a small okay to say small problems, let's say, for problems that we know that can be solved with machine learning. For an example, contextual search, recommendation engine, or some of the financial crimes that we see, like anti-money laundering and so on. So those are the problems that we know the cost that we have in every year to solve those kind of problems. And now developing the machine learning solutions, we expect that next year, after we have it run, for over a year, to see if we really achieve that an objective. So having more or less, an idea of what it would save, but we are not at the level yet to say, yes, we have achieved that, let's say, cost and saving, or you have increased the bank profit by X% by applying machine learning. I think we are still in the early stages of it. I hope that now, calculations of return on investment does pay off. But I think we are still in a too early process of an adoption to have seen still the fruit.
Thanks for the compliment for you.